Hi, welcome back to class 11 series. So we are seeing gravitation, chapter 8 gravitation of class 11. This is the part 4 video of gravitation class 11. So today we are going to look after important definitions related to gravitation and escape velocity. Before going on to today's session, let's recall our previous session. If you have not watched our previous session, the links are provided in the description. You can go and check it out. You can watch from part 1 to part 3, and if you watch those parts, it will be helpful for you and you can watch this part later. Now, let's go on solving the previous session question. Previous session we saw about the acceleration due to gravity. So now the question is, the mass and radius of the earth both are double, then acceleration due to gravity is. So now first, what is the formula we studied for acceleration due to gravity? Your G is equal to capital G capital M by R square. So this is a formula we studied for your gravitation. So let us consider the same formula for your first initial gravitational acceleration due to gravity. Later, your acceleration due to gravity, your mass and radius both are getting increased. In the sense, my G2 is equal to, your mass is also increasing as well as your radius is also increasing. G2m by 2r the whole square. Now what will be this, your G2? Your G2 will be 2mg by 4r square. So your 2 and your 4 can be cancelled, right? So you will be getting 1 by 2 mg by r square. So your G1 and this value are equal, right? So you can write, this is your G2 value. So you can write your G2 is equal to 1 by 2 G1 you can write. 1 by 2 G1 you can write. So here you can also write it as G2 is equal to G by 2. G1 by 2. So your B is your correct option here. Which is your correct option? B is your correct option. Clear? Now let's go for today's topic. Initially, we will be dealing with gravitational field. So what is gravitational field? So the gravitational field is a space around the mass or assembly of mass over which it can exert the gravitational force on the other mass. So for example you can take, so this one is your earth. This one is your earth. And we are also having the sun. Okay, we are also having the sun. Okay, earth and sun. So what do earth will do? Earth will revolve around the sun in a fixed position, right? In a fixed position called orbit. So around the orbit, what happened? The earth will move around the sun. So the earth is stably moving only on this axis. It is not colliding with any other like Mars, Jupiter. We have other planets also. And the earth is stably moving around its axis. It is because of some force that is exerted by the sun on the earth. Some force that is exerted by the sun on the earth. The earth is stably, the force exerted by the sun is holding the earth stably, in a stable way. So this force is called as non-contact force. Why it is called as non-contact force? It is called as non-contact force because the earth and sun are not coming in contact with each other. That is, they are not colliding with each other to produce any force. They are just producing the force in non-contact way. So they are called as non-contact force. So what happens? The sun is exerting some force on earth, so the earth is just holding in that place. So the space around this earth is called as the gravitational field. Okay, the space around this area is called as the gravitational field. Clear? Okay. So your gravitational field is denoted by the letter E. E vector is your gravitational field. Your gravitational field is equal to some force exerted on a massed particle. Force by unit mass. Okay. So force by unit mass. So how we can write the dimensional formula? Dimensional formula is ml t to the power of minus 2 by m, right? So your m and m will be cancelled. So your dimensional formula will be m to the power of 0, l to the power of 1, t to the power of minus 2. This is the dimensional formula for your gravitational field. Clear? Right. Now let's move to gravitational potential. What is gravitational potential? So gravitational potential is the gravitational field. In the gravitational field is the amount of work done in bringing a unit mass from infinity position to that point. So this is a point and your massed particle is at here. This is a point and this is your massed particle. So the distance is denoted by the letter r. R is the distance between them. So now your object should be brought to this position. This is the infinity position. So your object should be brought to this position. If your object need to be brought to this point you have to bring your object. Then what you have to do, you have to apply some force. If you are applying some force and the object is moving, some work will be done there. Surely some work done will be there. This work done is called as gravitational potential. This work done is called as gravitational potential. So your gravitational potential is denoted by the letter V. V is equal to minus G m by R, where your V is the gravitational potential and your m is a mass and R is a distance from the point mass. R is the distance from the point mass. Distance from the point mass. And m is the mass of the object. Clear? This is your gravitational potential. Okay. Now, what is gravitational potential energy? So gravitational potential energy of a body is defined as the amount of work done in bringing an object from infinity to that point against gravitational force. So similarly, you are placing an object at infinity position and you are bringing that object to the point where you require. You are bringing that point. Same R is acting there. R is the distance between them. But while you are bringing it against the gravitational force. So here what happens? Your work done on a unit mass is converted to potential energy when you are bringing it against the gravitational force. So that is called as gravitational potential energy. Okay. So now your gravitational potential energy is equal to mass into gravitational potential. Gravitational potential. What you know about gravitational potential? Your gravitational potential V is equal to minus G m by R, right? Minus G m by R. So your potential energy will be equal to minus G m by R. Why? Because here we are multiplying it with mass also, right? So now, your gravitational potential energy is denoted by the letter here. It is denoted by the letter U. So your gravitational potential energy U is equal to minus G m by R. So now I have to give you here two important clues. Okay, two important notes for 1 mark purpose. First one is when your potential energy, so your U is your potential energy, when your potential energy is increasing, when your potential energy increases, what happens for your distance? Distance will reduce. Okay, it will be reduced. Okay, it will be reduced. So because your u is inversely proportional to r. So if your u is increasing, your r will decrease. That is what I have written here. Next, second point is, if your gravitational potential energy, becomes maximum. When your gravitational potential energy becomes maximum or at zero, your R will be at infinity position. Your R will be placed at infinity position. These are the two important things you have to remember for the purpose of 1 mark. Okay? Right. Next, we are moving to gravitational potential difference. What is gravitational potential difference? So, gravitational potential difference is defined as the work done to move the unit mass from one point to another point. Till now, we studied only moving in point mass from infinity position to the point where we need. Here, we have two certain points. We are moving from a massed object, we are moving from one point to the another point. That's it. We are moving from one point to the another point. Here, we are not keeping the object at infinity position. That is the difference. That is the difference between potential difference and what we saw earlier, the potential energy and gravitational potential. Clear? Right. So now let's move to the very important concept, escape velocity. Okay. See, all the objects are moving with certain velocity, right? Yes, of course. So even when you are moving your object under certain gravitation, it is moving, no? Due to certain gravitation, it's moving down towards the Earth's surface. At that time also, it is moving with acceleration due to gravity, right? So now what they are coming to tell is, see, always the body need not want to go under the gravitational force. Sometimes it can escape from the gravitational force. When it escapes, that is called as escape velocity. So how it can escape? For example, satellite. Okay, we have satellite. What happened? Our satellite is sent from the Earth's surface. Okay, it is Earth's surface means our satellite is sent from the Earth's surface. If this is the outer covering of the Earth, it moves out of the outer covering of the Earth and it moves to the space, right? Moves to the space. How is this possible? How is this possible? Because we are giving some maximum, that is the velocity, we are giving some velocity to the satellite. The minimum velocity we are giving to the satellite at which it can be projected out from the surface of the Earth. So it is escaping with that particular velocity, that is called as your escape velocity. The minimum velocity with which the body moves so that it should be projected from the surface of the Earth. So it escapes from the Earth's gravitational field. This is called as your escape velocity. Okay, if the body or a satellite is given the escape velocity, its kinetic energy of projection will be equal to the binding energy. Okay, so this is how. So it moves with certain minimum velocity so that it can escape from the gravitational field and move out of the Earth's surface. That is called as escape velocity. That velocity is called as escape velocity. Okay, so here they are saying that the kinetic energy is equal to the binding energy. Binding energy. So your kinetic energy is half mv square. That will be equal to your binding energy is gm small m by r is your binding energy. This is, you can write it as VE because escape velocity are denoting with VE. Okay. So now your mass and your mass gets cancelled. So your VE will be equal to square under the square root. To this side if it goes to the numerator 2gm by r. Right. This is how you will get the final derivation. So this is your escape velocity. Okay, this is your escape velocity. Very, very important to remember. Okay. Now, we are going to express this escape velocity in terms of acceleration due to gravity. How you can express this in terms of acceleration due to gravity? So, what is the formula we have derived in the previous slide? our v, that is our escape velocity is equal to square root of 2 g m by r, right? This is what we derived in our previous slide. Now, what we know, our force is equal to mg, right? Mass into acceleration. Here in this chapter, we will be dealing with acceleration due to gravity. This is our first equation now. Our second equation, what we know that uh, force is equal to G capital M small m by r square. We know this, right? This is Newton's law of gravitation. Based on that, we wrote this. Let it be the third equation. Now, I am going to just see that here also force, here also force. Our LHS is same. So, you can equate the RHS. Since from looking after equation 1 and 2, what we can say is, we can say mg is equal to capital G, capital M, small m by r square. So, you can cancel out this m and this m. So, what will be the value of your gm? Gm is equal to g r square. Let this be your fourth equation. So, you are going to substitute your fourth equation in your third equation. When you substitute, what happens automatically? When you substitute, let me show you here. When you substitute, what happens? See, your VE will be equal to square root of 2 small g r square by r. So this r square and this r will be cancelled. So your VE will be equal to under the square root of 2g r. Under the square root of 2g r. So in this way, we have expressed in terms of acceleration due to gravity. Clear? Okay, our escape velocity is expressed in terms of acceleration due to gravity. Now, let's move and let's express our escape velocity in terms of density. So let us see how to do that. Now, what is the formula we studied for our escape velocity? V is equal to under the square root of 2g m by r, right? 2g m by r. Now, what is your mass of the earth? So actually, density is equal to mass by volume. So if you need your mass is equal to volume into density, right? Okay. So now, what is the mass of the earth? Mass is equal to volume is what? 4 by 3 pi r cube into rho. This is the mass of the earth. Now substituting this value here, let it be for equation 1, let it be the equation 2. So now what I am going to do is I am going to substitute 2 in 1. When I substitute, what happened? We get RV is equal to square root of 2gm by r, right? So in the place of m, I am going to substitute this 2g by r will be as it is into 4 by 3 pi r cube rho you will get. Now what you can do, this r and this r can be cancelled, right? And other things you can't cancel, that's all. So if you cancel this, what happens? Here you will be having 2 as your remainder. So under the square root, 4 under the square root, all are in multiplication. So 4 under the square root is 2. Square root of 4 is equal to 2. And r square can be written as r. So your VE will be equal to 2r. How I got? Because 4 square is 2, I took that outside. And r square is r, I took that outside. Now under the square root of 2g, 3 is there, right? 2g pi rho by 3. So this is my escape velocity. I have expressed it in terms of density. Okay, I have expressed it in terms of density. Clear? Hope you got it. And thank you so much for watching this video. This is the end of this part. And I'll be coming up with the future parts of this chapter. And if you like this video, kindly like and subscribe to our channel and click the bell button for future notification. Thank you so much.